Hello guys, so in my last video we explored how a simple C program becomes an ELF binary, like by inspecting sections, symbols and flags using object dump. Now today we'll complete this journey from pre-processing to assembly, object creation and manual linking, all on my Raspberry Pi. Alright, so to start with, let me remove all the files that I would have um, created before or generated. Test.s and final clear ls and cat test.c. Good. So this was our code. So with this one line of code, we'll go through next step to pre-processing of this code. All right. So if you run gcc-e flag, all right, and you do a test.c -o test.i, and now we could check if it exists, and then less test.i. What we get? We just see main. We don't see anything else here. All right. I was expecting to see more like the pots and stuff like that. So your test.i, it should expand and show you the macros and headers. And it's useful for debugging any include parts and conditional compilation stuff, but I didn't see anything there. All right, so we will proceed to the next stage, which is the going to the assembly level, and we're gonna use this flag here, dash capital S test, right, dot C dash O test dot S ls. We have that file, so now let's take a look at it. Let me clear the screen. Less test.s, and here you go. This is your assembly instructions. All right, so your assembly file, the .s file, right, it contains your ARM instructions, readable but not executable, right? So it helps them, like a developer, to understand what the compiler emits. So these are your instructions. All right, now after you have your assembly instructions, the next stage gonna be to get to an object file. So to go there, we're gonna use gcc.c. Am I getting one of those moments again with my computer? Test.s, which was the assembly level file, -o test.o. Now we have a test.o. Now we can, now in my last video, remember I used readelf and object dump. I did not use nm. nm is more very brief. Like if you use nm test.o, right, you get that. But if you use object dump, right, -d test.o, you see you get a lot more information. All right, so we're done with that. We are looking here to see what's happening at the object level. Now after you have the object file, right, you can get into in the object file. This is where you have your symbol tables and sections begin to take shape. Now your manual linking, let's say you go the manual linking way. So if I do ld test.o, right, dash o as my final file, dash lc dash dynamic dash linker, my Raspberry Pi, this would be the part. So dash ld dash linux dash arm hf dot so dot 3. Enter. Now it's giving you a warning here. Cannot find symbol underscore find entry symbol star, defaulting to this. So if I try to run this program, I might have a segmentation error. All right. So let's do that anyways and see what happens. So now before I run it, let me just show you this. We are here. Now final is my binary, but I have an error there, right? So if I do final here, I should get a fault. Segmentation fault. Now the way to fix this, if I do, now there are some other manual way, but the easiest one would be if I do gcc test.o, right, dash o final. This should take care of business. Now if I go back and run final now, it should have returned 42 and it returned nothing, but it did not give me an error. So why it didn't return 42 is my next question. So I will go and explore that right now and see what happens. Okay guys, so why did I say you should see the 42? I should have run my echo command here, right, to get this value. Here you go. Sorry about that. It was just a moment because I had a segmentation fault. I had to look that up a little. There's a manual way to correct this error, but the easiest way is to just compile with GCC. It brings in all the necessary files, like which I was missing to find the symbol entry start. So it's a good thing to use GCC if you can, than to go into all the other files that you might have that you can compile manually with. All right, so I think here now we have gone from source to binary every stage, revealing how the code becomes a working program, right? So these tools aren't just for curiosity, they are essential for debugging, optimization, and general embedded development. There's a lot, I guess, to explore more, but you can use help files and you can get to that. I hope what I didn't show, did I show that? Yeah, I did that. That this here, only nm just gives a brief, right? Shows main, whereas your object dump, right? Your object dump dash d test.o gives you a lot more info. So I did place this poem in LinkedIn, and I talked about how I convert one line of code into a binary and choose how it works. So this video was supposed to complement that and finish this whole compilation process. All right. So this gives you an overview about how at every stage, right, what happens with a code. And you can think of it like this. The pre-processing is like you lay out all your ingredients for cooking, right? You put everything, you know they are there. When I say like you're gonna look at parts and all of that, you know that okay, this thing is some distance. I know the path to it, so I can see everything. So the assembly now, it's where your assembly instruction is like your recipe. All right, like take this, add this to this, move this to this point. Now the object file is like when you make the meal, you package the meal. You mix everything up, all the ingredients or whatever you do with them, you get a meal, you package it. And the linking is like you're ready to deliver, right? So if you see it from that angle, my pre-process, I have a raw code. My pre-processor is like I'm laying out all the ingredients. I know where they are, right? Are the parts of them. I can see everything. They're expanded, right? Creating clarity. Now I make this product or this food or whatever I'm making. So that is where my assembly code comes in. It's like how do I do it? The recipe. What do I need to add to what and how to do it? When I have it done now, that's my object file. It's my package. And then, well, I have this file now, or I have this package. I want to link it. I want to use it now. All right. So that's where the linking process is, right? It deal with like delivering the system, right? Is a delivery system. So this is where I'm gonna start this video. I hope it makes sense. At least it makes sense for me. So I will stop here. You guys have a good Saturday. Bye for now.